Good evening. My name is AMIRA binti Muhammad ZAHAM, metric number A195662. My team members are Alif Hakimi, Muhammad QAYYUM, and VINESH. We are from Group 28. Today, we will be presenting our chosen paradigm, object-oriented programming. The computing paradigm is utilized in performing computation, organizing data, developing higher-level systems, and fixing issues using computers. Effective computing paradigms are useful in analyzing, creating, and applying solutions for complex system problems. There are a few computing paradigms such as object-oriented programming, procedural programming, functional, imperative, and declarative programming. Also, why the computing paradigms is important, it is because it enhances data security, where data hiding and abstraction methods are the best way to ensure security in order to manage the application smoothly. For instance, the program only shows the essential data and hides the code's complexity from users. This is to prevent users from editing or changing the code. Next, the code reusability. Programming concepts like encapsulation, polymorphism, and inheritance encourage code reusability that aids programmers in writing easy, modular, and reusable code. It is less time consuming and improves maintainability. Lastly, it encourages flexibility. The way paradigms are structured and composed are different from other paradigms, which allow programmers to pick the best option to solve the problem. In this task, we have chosen object-oriented programming, OOP, because it promotes modularity, reusability, and encapsulation. Object-oriented programming (OOP) is a close representation of the real world that combines both data and function into a single unit called object, which is useful for creating modular, reusable code. Programmers are able to replace or change code without messing up the other parts of the program. The existence of OOP happened during the 1960s when the Simula programming language was developed. Simula established the idea of classes and objects, which served as the basis for current OOP languages. Then, Smalltalk's development in the 1970s contributed to the increased popularity of OOP. In 1980, OOP became popular when languages like C++ and Smalltalk were released. In the middle of the 1990s, OOP increased in popularity when Java was released. Furthermore, the main characteristics of OOP are classes and objects, encapsulation, polymorphism, inheritance, and abstraction.
When it comes to defining the object-oriented paradigm, it is important to recognize that the core tenet or driving principle is trying to represent real-world entities as objects in code. The focus is on programming with the object in mind as a sum of what it can do, also known as methods, and what fields of data it has, also known as attributes, rather than focusing on logic or functions. Supporting this, object-oriented languages adhere to this paradigm by allowing for different relationships between objects and classes to exist that allow us to depict the real-world relationship of these entities better. Moving on to the object-oriented paradigm architecture, we have classes that describe attributes and methods of similar objects that belong to this class. Attributes belong to classes as empty fields, which are then filled up by objects that store data in these fields when they are instanced from a class, and objects are typically the real-world entity that we are programming in mind with. Methods are defined functions existing within a class and has its functionality encapsulated within each object. Here we have a sample code for a food program that helps create and describe food. So starting off, we have the abstract class food that has two private variables, calories and flavor profile. There are two constructors for this class, which illustrates overloads, which is polymorphism within an object-oriented paradigm. The food can either be created with calories or and flavor profile or just calories. Moving on, we have getter and setter methods to change the values of these private variables. Getter and setter methods are examples of encapsulation within object-oriented paradigms. And lastly, we have an abstract method that helps abstract data from the user and hide it, which is abstracted within the object-oriented paradigm. Moving on, we have a subclass burger that extends food. After explicitly stating the two same constructors, we can override the described method, which is also a form of polymorphism. In our driver code, we create a burger using the first constructor. Here we can also use encapsulation and use the getter setter methods. And here we can also create another burger with the second constructor. The output is as expected.
There are three main characteristics of OOP, which are encapsulation, polymorphism, and inheritance. For the first one, encapsulation, it is wrapping up variables and method in classes. Encapsulation helps us in data hiding, promoting data security, and code organization. For the second one is polymorphism. Polymorphism literally means many forms, and it has the ability of a message to be displayed in more than one form. Polymorphism can be achieved through two methods, which are method overloading and method overriding. And it also enhances flexibility by allowing different objects to be treated uniformly. For the third and final characteristic, which is inheritance. Inheritance allows a class to inherit properties and methods from another class. Inheritance promotes code reusability and establish a hierarchy of classes. For example, a parent class or superclass can pass down their properties and methods for subclass or child class to use. The strengths and weaknesses of OOP. There are three main pros and three main cons. The first pros is code reusability. It allows for code to be reused in different parts of an application. This can improve code quality and save time. For the second pros is modularity. Modularity allows for code to be broken down into smaller and manageable pieces. This promotes faster development and changes in one part does not affect other system. For the third and final pros is it allows to hide implementation details of an object. This promotes data security and integrity by limiting access to data. For cons, for the first one is complexity. Can have many complex code, especially dealing with large system, and this can lead to difficult to debug and maintain code. For the second con is steep learning curve. It takes time to learn OOP as many concepts such as inheritance and polymorphism are used. And the third and final cons is overhead. Overhead can OOP can have slow performance. It is more verbose and additional abstraction layers by objects and encapsulation. OOP also require more memory and processing power.
We will be comparing 5 different programming paradigms, each with its own change from previous paradigms and characteristics related to processing speed and memory. The first one is object-oriented programming (OOP), where it marks a transition from procedural approach to object-based design, emphasizing encapsulation, inheritance, and polymorphism. Although it introduces some overhead in processing speed due to method dispatch and object management, it typically consumes more memory because of object instance. Imperative programming, on the other hand, introduces control flow mechanisms such as loops and conditioners, which focus on multiple state and variables. It is generally efficient, though prone to errors, and memory usage depends heavily on the data structures employed. Posterior programming involves executing functions sequentially and emphasizes step-by-step instructions, resulting in efficient performance with lower memory usage compared to OOP due to direct function calls. Functional programming centers on immutability and proof functions, which can lead to delays from function composition and recursion, but tends to use less memory due to its immutable nature. Lastly, declarative programming shifts from detailed step-by-step instruction to high-level descriptions, which performance vary based on the specific declarative language or paradigms in use. In this paradigm, memory usage is typically managed by the runtime environment. Next, for our analysis, object-oriented programming (OOP) is great for designing complex systems and managing large code base. Functional programming excels with parallelism, testability, and clarity. Procedural programming is simple and effective for certain tasks. Imperative programming is ideal for performance optimization and low-level control. And lastly, declarative programming makes expressing intent easier.
So, what are my final thoughts of OOP? In my opinion, OOP are basically a well-organized code. This is because of the concept it uses, such as inheritance, polymorphism, and encapsulation. OOP allows code reusability, which speeds up the development and increases flexibility. And it also allows code to be divided into manageable pieces, small pieces, and avoiding large files. In my opinion, new developers can adapt and understand better, or those who want to return to the code can adapt to the code better. Debugging and testing code can be done quickly as OOP allows objects to only to be concerned with function and data they contain due to modality. Although OOP is complex and a steep learning curve, every programmer has to understand the concept of OOP as it is a vital part to build scalable and dependable software.
For my final thoughts, learning object-oriented programming as a computer science student really helped me a lot in terms of writing organized code by breaking down complicated problems into manageable parts. OOP gives you a quick grasp of how real-world scenarios work by using concepts like polymorphism, inheritance, classes and objects, encapsulation, and abstraction. Additionally, OOP benefits like code reusability help in eliminating duplicate code while increasing the programmer's efficiency in developing high-quality projects. Even though utilizing OOP would consume memory, it is important to find a balance between its benefits and drawbacks to create a good architectural programming design that aligns with the requirements needed.
For my final thought, I think it's really beneficial to learn object-oriented programming or OOP because by doing so, I can organize my code better with solutions I've already created and focus on the main features. Easy management through encapsulation, simplification of complicated systems by abstraction, facilitating code usability using inheritance, and enhancing flexibility through polymorphism are some of the benefits associated with it. All this together help to improve my programming skills by making them easier to manage, and it's one way of getting me ready to work with my new programming language and frameworks.
Through studying the object-oriented paradigm, I've been led to appreciate the modularity which helps with not just reusing code, but also when organizing your code for a software project. In addition to this, the idea is really simple and intuitive to me as it helps me to represent real-world problems within code itself, and it's just something that I seem to really enjoy and am comfortable with using as a paradigm. Object-oriented languages are also pretty efficient, which help with programming tasks.